Agent-based modeling is a powerful technique for simulation of dynamic complex systems and observing the emergent behavior. With this method, you can model traffic scenarios, planes over a runway, or robots in a manufacturing facility. Actually, anything where you have multiple entities that operate independently and change behavior based on the scenario. In this agent-based model of driving scenarios, the entities or vehicles are separated and independent from the environment or scenario in which they operate. In this example, you can set the number of each type of vehicle and other parameters, and choose the driving scenario, such as 2-lane merge, 2-lane switch, 3-lane merge and switch, 4-lane merge and switch, 1-lane curve, and 3-lane curve and switch. You are not changing the agent pool each time you switch the scenario. The agents are reused to operate in the different scenarios. Let me show you how this is modeled. In the agents pool, we have two different types of vehicles. Each type of vehicle is made up of a driver strategy, otherwise known as a planner, and vehicle dynamics, which is the plant. These are in for each blocks, which is a type of subsystem that repeats execution on each element and concatenates results. This makes it possible to simulate multiple vehicles of the same type with different behaviors at the same time. Inside the driver model, it checks whether it is safe to merge, and then uses a stateflow state chart to calculate lateral and longitudinal acceleration. This model of driver behavior could easily be replaced with a different model of driver behavior that has the correct outputs given the inputs. The world and broker takes in the ADAS data output by the agents pool and feeds it into one of the chosen scenarios. The scenarios are modeled with variants, which allow you to make one block active based on a condition. If we look at the 2-lane merge scenario, we see a SimEvents world model where entities are generated, routed, queued, and terminated. What is connecting the agent pool's driver strategy models and the scenarios is a broker. The broker is the intermediary between the agents and world and gives information to the world from the agents and vice versa. It is the glue that combines the two domains together. For instance, vehicles in the scenario are only allowed to exit the system when the hit crossing block shows that the position has hit a limit using information from the agent pool. Then the vehicles are removed from the simulation with the terminator block. Also, the perception and localization for each subsystem takes in the ADAS data from the model and maps that onto the road information. If you were going to update the model with different map information or a different road shape, you would need to update this subsystem. With this flexible framework, one can model traffic and ADAS scenarios, but it is easy to imagine extending the framework to model other types of vehicles or agents and the environment in which they operate.